All right, welcome everyone to the AP Calculus AB series. My name is John. I took the AP Calculus BC exam 3 years ago and I got a 5. Now I'm getting my master's in mathematics. I'm almost done with it, and I believe that I can help you guys do well on the AP Calculus exam yourself. We're going to go through every single video, every single thing you need to know about the calculus exam in this series. So without further ado, let's go ahead and get started. All right, so the first thing we're going to do is something called the limit. But even before we start with the limit, what the heck is calculus? Calculus, in its simplest form, is studying change. We are studying how things move. If there's a bucket of water and less water is in it as time goes on because of precipitation or whatever, we can model that. And that's useful in the real world for an infinite amount of things. And the way we're going to build up the mathematical tools to study these changes starts right here. Starts with this thing right here called the limit. We need to understand this, and if we can understand this, Unit 1 becomes very easy. So let's take a look at it. This is called the limit. All right? This is called the limit. And this lim x arrow a f of x equals L, what the heck are we saying by that? That's the question, all right? All I'm saying is this. As x gets really close to a, approaches a, and that's what we mean by that arrow, then f of x gets really close to L. And that's all the limit is saying. As x gets really close to a, and when I'm saying approaching a, the arrow, I'm talking it's getting very, very, very close to a. Then, what is happening to our function? We're going really close to a in the domain. What's happening on the y values? Remember, the function gives out the heights, the y values. Our y values need to start getting really close to this value, L. And that's what a limit is, all right? All we're doing today is just discussing verbally and maybe a little graphically what the limit is. So I have this x arrow a. What am I saying by x arrow a? As x arrow a means x is getting extremely close to a in the domain. And a is just some number. X is getting really close to a. That's what we mean by this first part right here. As x is getting really, really, really close to a, what can we say about the y values? The heights, f of x, our function. Well, then f of x needs to start getting really, really close to L. And that's what we're saying by that arrow. Then f of x and that's it. That's all we're saying. As x gets really, 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 really close to a in the domain, where is our function getting really, really close to on the y-axis? So let's go ahead and try and graph this so we can try and see what's happening visually. If I make a coordinate plane, all right, so our y-axis will be labeled here, and that's the vertical line. And the x-axis is the horizontal line. And let's just say that our point A is right here. Now remember, all the function is taking is it's taking numbers on that horizontal line, that x-axis, and plugging them into something. Could be an equation. And it's getting out numbers on the y-axis, the vertical line. So let's pretend that this right here, that's our function, f of x, okay? And I want to describe the limit as x approaches a of f of x. We want to find what value L we're looking at. All right, so that's what we're trying to describe. We're trying to describe this graphically. So when I say that x is getting really close to a in the domain, I'm saying that we're taking points that get closer and closer and closer to A on the x-axis. And they continue to get closer and 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 closer to A. And the idea here is we want to know what the heck is happening on our function when we plug in points that get closer and closer to A. Well, it starts here on this side, and it starts over here on the other side. And as we keep going closer and closer to our point A, we start to see that our function hones in on this point right here. That's our L. So that's all we're saying. We're saying as we get closer and closer and closer and closer to this value A on the x-axis, where's our function getting closer and closer and closer to on the y-axis? And whatever that thing it's getting really close to on the y-axis, that's what we call L. And that's what the limit as x approaches A of f of x is equaling L. And that's it. That's episode 1.